Hey everyone. In this episode of ITS Now, we're going to be looking at the very humble pedestrian push button unit. These are used worldwide and provide pedestrians with a valuable way to cross the road. I'm Alistair and this is ITS Now. Okay, so let's push that button and get started. Pedestrian push buttons were invented by Charles Adler Jr. The first installation was in February 1929 at the intersection of Charles Street and Cold Spring Lane in Baltimore. This was obviously quite a rudimentary affair, with a small button screwed to the wooden pole they were using. The most sophisticated element seems to be the accompanying sign, which shows the origin of push button. However, these days, their ubiquitous nature means that many of us simply don't notice their existence. Around the world, the designs of push buttons varies greatly, from the simple to those with hidden features, including audible and tactile feedback to users, including directional information and visual indicators. Some have done away with moving switches and use touch-sensitive inputs, and some are used for cyclists or equestrian use, while some appear vaguely familiar, and some which are elegant in their very simplicity.
Please remember to click on the like and subscribe to keep updated on ITS Now.
In the UK, people are probably most familiar with the Pelican style of push button unit, or PBU for short. There are a few different variants of this, but this type is no longer installed in the UK. Although this style of crossing uses pedestrian signals on the opposite side of the crossing, referred to as far-side signals, the push-button unit includes a backlit wait indicator, which illuminates to show that the traffic signal controller has received the demand. The wait indicator then extinguishes when the green walking figure illuminates. All the varieties of PBUs are housed in rugged cast metal enclosures. The indentation on the rear allows them to be mounted onto the cylindrical poles used for traffic signals in the UK, which are normally 114 millimeters in diameter. These are fixed into place using a standard traffic signal U-bolt. This protrudes from the signal pole through the two mounting holes in the rear of the PBU, which are then secured with nuts inside the enclosure. The electrical connections pass through a grommeted hole, allowing a cable to be drawn through from inside the traffic signal pole. The rear of the units is coloured yellow, but the front is black, which provides a better contrast for any signals displayed on the front. The cases are opened for maintenance using a standard traffic signal T-key, which unscrews and allows the front to be hinged downwards. The design of the different variants of permitted PBUs is set out in the traffic signs regulations and general directions requirements. This far-side signal variant is to diagram 4003 and is the modern equivalent to the Pelican crossing, referred to as a PEDX crossing. These are increasingly used in urban environments with countdown signals. We have an upcoming episode to explain the actual functionality of the different crossing types. The preferred modern style of signalized crossing uses pedestrian signals on the same side of the crossing as a pedestrian. These are therefore referred to as near-side signals. There are a number of different variants for these. The pedestrian version is called a puffin, and the standard combined PBU to diagram 4003.1 incorporates the push button, the wait indicator, which is a red indicator adjacent to the push button. Most modern units use a circular indicator around the push button. and the pedestrian red standing and green walking figures. These can also be implemented using a separate pedestrian demand unit to diagram 4003.8 from the near side indicators to diagram 4003.1a. These are also sometimes used as supplementary displays mounted higher on the signal pole above the standard combined units for situations which are heavily used by pedestrians. This overcomes the issue of low-level signals being obscured by pedestrians standing in front of the unit. The pedestrian demand units are also sometimes used at busier or wider crossing points. I'll show an example of this a bit later in the video. Another version of the near-side signal is a toucan pedestrian cycle, combined crossing to diagram 4003.7. This includes a bicycle symbol with both of the red standing and green walking figures. The actual push button unit itself, the rest of the items within it are identical to the puffin unit. The remaining type of crossing is a Pegasus crossing to diagram 4003.4, which is used at equestrian crossings. As can be seen in this picture, some of these are mounted higher than normal PBUs to allow riders to press them without having to dismount.
So what we have here is a puffin, but you can see it's using split units. So it's got the near side indicators in a separate unit to the pedestrian demand unit, and so you can see here the LED display in this housing. So it's a metal housing, very rugged, yellow back, and you can see how this mounts into the pole itself. So the U-bolts are in behind here, and that is seated down firmly on there. And then the front panel, you've got the T key at the top here, and then this, you undo that, the whole thing unhinges forward so that you can get in it for maintenance activities. And then down below we've got the pedestrian demand unit. Again, same sort of housing, obviously smaller. You've got the T key in the top, hinges, comes down, and on these you've got the weight indicators, these LEDs around the outside, and the push button. And then the bit that a lot of the public don't know about is the rotating tactile cone there, which, as you can see at the moment, is not doing anything. But when I press the button, the weight indicators come on there, and as soon as the green man goes, which may be a little while, there's not much traffic around here though at the moment, so we'll see how long that takes. But you can see that that's stationary at the moment. I don't know if this is on a split, so probably won't have audibles. Right, that's rotating. Green man's come on, and we cross.
Features to assist users with visual and hearing impairments are commonly fitted to PBUs. There are two accessory holes in the bottom of PBUs which are used to mount these items with. The first of these is the rotating tactile cone that we just saw operating in that video. This is a ribbed metal cone that protrudes from the underside of the unit. The cone, which is driven by an electric motor via a gearbox, rotates when the green walking figure is displayed. By placing their hand on this, users can tell when it is safe to cross. These should be installed in the right-hand accessory hole when viewed from the front of the unit. These should now be fitted to all new installations and retrofitted to existing sites wherever possible. Audibles, which are the beepers which sound when the green walking figure is displayed, are also usually mounted within the PBU. These are normally installed in the left-hand accessory hole. I'm frequently asked why all signalised crossings are not equipped with audibles. The reason for this is that these cannot be installed where other crossings are located within close proximity, such as a split crossing or at a signalized junctions, because of the danger of users mistakenly starting to cross when another crossing goes to green. This can be an issue in some locations, such as Australia, where all crossing arms are equipped with an audible signal. I know that I've even started to cross when an adjacent crossing went to green, so it is something that requires care when implementing. For safety, all the electrical circuits within PBUs are extra low voltage, so that means a maximum of 50 volts RMS. So in the event of units being damaged, users will not be put at risk of suffering an electric shock. In older Pelican-style PBUs, the weight indicator is illuminated with a traditional lamp. However, it is becoming increasingly difficult to purchase these, so to save energy, many authorities have installed LED conversions. All the near-side units solely use LEDs. This example shows a typical PBU arrangement for a split crossing with a staggered island in the center. The pedestrian near-side indicators are mounted on the signal pole on the side of approaching traffic, so that users can see vehicles whilst also looking at the signal. Therefore, in this example, for the closest crossing, because traffic is only approaching from the right, the signals are both located with their backs to this traffic. Additional pedestrian demand units have to be installed on the right. So on crossings located on one-way carriageways, an additional pedestrian demand unit has to be installed on the right-hand side of a pedestrian approach, where the near-side indicator is installed on the left-hand side of the pedestrian approach. This provision allows users with visual impairments to find the push-button unit. The additional pedestrian demand unit that has been installed at this site on the left-hand side of the nearest approach isn't strictly necessary, although it is a useful addition at busy or wider crossing sites. Depending on the orientation of a split crossing, it is sometimes possible for pedestrians waiting to cross to be able to see the pedestrian signals intended for users on the other half of the crossing. Because these operate at different times, it is very important that a distracted user doesn't start to cross at the wrong time. To overcome this issue of see-through, as this issue is referred to, affected indicators should be fitted with narrow field of view optics. In this example, both the near-side pedestrian signals on the central island have been fitted with these, so that we can't see what is displayed on the other half. The examples show a standard and narrow field of view units. This can also be an issue at sites with unusual central islands, such as triangular islands found at some T-junctions on one-way road systems. The physical location of the PBU has to be installed so that it relates to the location of the crossing. It should be offset so that it is 500 millimeters from the side of the crossing. There is also a minimum clearance distance between any street furniture and the edge of the carriageway. So in this example, the edge is defined as the face of the curb. The absolute minimum is 450 millimeters, but this is often increased to 600 millimeters or more on high-speed roads or locations on the inside of a curve. Because of this, the pole is normally mounted with a clearance of 500 to 800 millimeters. The units also have to be installed to ensure that the center of the push-button unit is between 1000 to 1100 millimeters. Some of the DFT guidance incorrectly states this dimension is to the bottom of the unit itself, from the surface of the carriageway. The orientation of the units is also important. Far side push-button units are normally installed at 45 degrees to the curb line, but near-side demand units are usually at a shallower angle of 30 degrees. This provides clear sight of approaching traffic whilst looking at the unit. Most push-button enclosures include an amount of adjustment in their mounting to optimize their orientation. However, if the unit needs further adjustment, it is sometimes possible to rotate the signal pole in the retention socket foundation, although any other equipment mounted on the pole will probably need to be adjusted afterwards. Many users can find using signalized crossings difficult, especially if PBUs are not located so that users can operate them easily. For those with visual impairments, the PBU needs to be located where they're expecting it to be. And for those with mobility impairments, it can sometimes be impossible for them to reach the button, as demonstrated here by Philip. To overcome this, some sites have been equipped to work with specialist smartphone apps, which allow users to place a demand to cross without having to physically press the push-button unit. During the pandemic, it became apparent that users were concerned about touching buttons because of the perceived risk of picking up germs from them. Because of this, a number of different initiatives were implemented by different authorities. Some put in a permanent demand for pedestrian phases so that users didn't need to press the button. And certainly during this period, because of the lower levels of traffic, this didn't cause too much congestion. Another solution has seen the introduction of touch-free sensors in PBUs to allow users to place a demand without having to physically touch the unit. Technologies used have included infrared and ultrasonic transducers. So lots of information there about pedestrian push-button units. If you've got any comments or queries about these, please feel free to put those down in the comments below. Was there anything that you didn't know about, or something else that we should feature in our series? We've got some other episodes coming up sort of related to different types of technologies. We've got inductive loops, a whole episode about those. We've also got above ground detection as well. And there's a whole series of more episodes coming up. So if you haven't done already, please subscribe to our channel. It would really help us. And a very heartfelt thank you to everyone that's done so far. Thanks for watching. See you next time.